Hello viewers, welcome to RK Keynotes. In the predictive modeling model, in the previous videos we have seen how to treat missing values, how to detect outliers and how to fix those outliers using few techniques. In today's video we will talk about variable transformation. Before getting into the video, if you have not subscribed yet, do subscribe my channel to get more updates. And also if you have got any queries, feedback or requirements, do let me know in the comment section, which will motivates me and also which helps me to make a video on the required concept. Let's dive into the video now. So now what is variable transformation? Basically variable transformation in the sense we are going to do some changes or some replacement for a variable. So it can be replacing variable with some function and changing the distribution, which means that you might have heard about skewed distribution, right skewed and left skewed. So we are going to eliminate right skewed distribution basically, and we need to generate a normally distributed one so that we can analyze or we can predict those errors in an easy way if it is normally distributed. And we are going to do changing the relationship with other variables. So this is what about variable transformation. Now users, why do we use variable transformation or why do we need variable transformation? The first thing goes like this: variations in variable can be changed. What do you mean by this variations in variable? Let's say that you have got 100 records and which is in kilometer basically, this column, and you have got 90 records in kilometers, like 5 kilometers, 10 kilometers, 20, something like this, and the last 10 records are in miles. So what do you do now? So is it easy to analyze or extract a common result from this? Obviously no. So what we have to do is we need to do some changes, like this miles should be converted into kilometer. Then after that we will consider this whole 100 records, and then now we can analyze the results or predict some results in an easy way, right? So that is what about variations in variable can be changed. And transform non-linear into linear relationship. Basically non-linear relationships in the sense, in a graph you might have seen that there will be bunch of dots like this in a way, so you are unable to figure out what is the relationship between the variables and all. So if we convert this non-linear into a linear one, you will be getting something like this, and you can now analyze the results in an easy way and create symmetric distribution from skewed distribution. As I said that we are going to eliminate this skewed, mainly this right skewed distribution. So I'm going to show you how it is going to be. So the right skewed distribution basically looks like this, which is yeah, like this. So this is a graph, and now basically we need to eliminate this. This is right skewed, and you see this is what about left skewedness, and we are trying to eliminate this, and we gonna get a symmetrically distributed one like this, so that we can find all the values in an easy way. So that is what we are trying to do with this variable transformation. And so to do all these changes we need few methods, right? So we have 4 methods. One is logarithm, and the second one is square root, and third one is cube root, fourth one is binning. So logarithm can be used to reduce the right skewedness. Just now we have seen what is right skewedness, and square root can be applied for positive values. Cube root can be applied for both positive and negative values, and binning we are going to apply it in this Titanic data set. For example, age is there and it is a continuous variable, we know that, and we are going to split these bins, like 0 to age 0 to 15 are children, and above 15 to 80 are adults. So which means that now we have got categories, right, like children and adult. So binning is actually converting or transforming continuous variable into a categorical variable. So that is what we are going to perform. Alright, now let's dive into Google Colab for the practical session, and also you can follow my videos and updates in rkkeynotes.blogspot.com. Let's dive into Google Colab for the practical demo. Over here I have imported all the necessary header files which I require. One is pandas and to read CSV dataset, and another one is matplotlib.pyplot. We are going to draw some graphs. So I'm going to run this, and this is fine. Read the data set into the variable df, that is data frame, and I have got, you can use any variable over here, no issues. And I'm going to display the first 5 records using head function. Yes, it is done. So first let's display a histogram for the age variable. I'm gonna write df age dot plot hist, and you'll be getting a frequency table for the age variable. And if you see this, this is left side, and this is basically, you see that there is a curve towards right. This is called right skewed actually. So we need to eliminate this right skewedness. So for that, just now we have seen few methods like log and square root, cube root, and binning. So we can apply this one, and let's check this. So the first task is to apply log. We're gonna deal with some numerical calculations. So we need numpy library. I have entered here, and numpy dot log the variable that is age plot dot hist. Let's see this, which is going to eliminate the right skewedness or what? No, it is not. See, now this is completely left skewed, right? If you draw arc like this, it goes like this. So this is not suitable. Let's apply square root. Just change this log to sqrt, and you'll be getting a square root for this age variable, and this is pretty much good. If you see this, you can draw something like this. So this is a bit symmetrical. Let's try with cube root. We'll see the result. Oh, this is not acceptable, so we'll stand with square root. This is fine for us. Okay, so now how about this binning? Binning is actually used to transform, as I said, that continuous into categorical. So here, as I said, we are going to categorize the people in the data set, that is 0 to 15 lies in children, and above 15 to 80, that is, if you see this frequency table, you will get to know, yeah, this is what I'm talking about. So this is the whole data set, that is age and people, and 0 to 15 we can, so this is our wish, we can consider as 0 to 10 also. And just for example, I have taken this 0 to 15, and 16 to 80 is adult. Let's do this. So here the bins are defined, and I'm going to group them into 0 to 15 as children, and above 15 to 80 as adult. Run this, and now I'm going to use cut function to cut these bins, and I'm going to have I'm going to store this one into a type variable. In our dataset, there is nothing called type, which means that after this embarked, we are going to get a new column, and in that column the results will get stored. Like if it is now this is above 15, right? So this is going to get stored as adult. Let's see this, how it works. And I'm gonna run this. So within this cut function, I have mentioned age, and I have passed these bins and this group. So run this. Yeah, to check this, I'm gonna display again the first 5 records. You see this, we have got type, and in this type you see that the age is 22, it is showing as adult, 38 adult, fine. So now we just want to know the count, how many adult and children are there. So for that, the variable name is called type. So df type dot value underscore counts. If you do this, you will be getting the count. 631 adult and 83 children are there in this data set. So this is what about transforming a variable. And in the next tutorial, so now we are done with predictive modeling model, and the next tutorial we are going to apply some machine learning algorithm, and we are going to do some projects. So do practice all the concepts if you have missed anything, and also if you like the video, hit the like button and do share the videos. Hope you like this video, and thank you, and thanks for watching the video.